Welcome back, everyone, to the eCoreAcademy e-learning platform. My name is AJay Raj, back with another Algebra 1 video for you all. And today's lesson topic is going to be going over the explicit and recursive formulas, two very interesting and very useful formulas when it comes to your arithmetic sequences. So the two main goals for this lesson are to identify what exactly these two formulas are in their equational format, what the explicit and recursive formulas are, and how exactly we can use them in relation to arithmetic sequences. So if you go back to my previous video, I went over arithmetic sequences in the Algebra 1 playlist on our YouTube channel at our homepage. You can see for the Algebra 1 course, we have arithmetic sequences coming right before this lesson. So please make sure to check out that video. I go over the basis of arithmetic sequences, essentially number sequences that have common differences between each consecutive term, and you can identify that with a function rule. And today we're going to be utilizing the different properties of those sequences, plugging them into our formulas, and identifying really complex sequence terms in either the future or previous of any terms that were given in that sequence. So I will explain that if you're confused. Don't worry, we'll go through this completely in depth. I'll gut this entirely apart for you guys. But before we jump into today's lesson, please make sure to do 4 things. Please make sure to smash that subscribe button, hit that like button on this video, turn on post notifications, and don't forget to leave a comment down below. Without further ado, let's jump right into it. So these are called your arithmetic sequences formulas, your explicit and recursive formulas. They apply specifically to your arithmetic sequences and the different properties of your arithmetic sequences. So explicit and recursive overview. I'll go over exactly why we utilize these formulas in generality, and then I'll go over each and every single one, explaining what they are in definition-wise in correlation to Algebra 1, and then of course I'll go through practice problems for each one. So when you're given an arithmetic sequence of numbers, you can create a function rule for the sequence no matter what the common difference is. So once you're given a sequence of numbers and they have a common difference between each other, like 3, 6, 9, 12, they're all increasing by 3. When that's basically a linear arithmetic sequence, you can always create a function rule for it. It can be y equals mx plus b when you have a common first difference. It could be a quadratic equation, y equals ax squared plus b, when you have a common second difference, so on and so forth. You can always identify sequences with function rules. However, when you're asked to discover previous and future terms in a sequence, and when you're given a data set, an actual sequence itself, you want to discover what the nth term is, like some future term that you want to discover in that sequence, because sequences go on forever. So you want to discover what the nth term of a sequence is, previous or future terms in a sequence. When given a data set, it's actually quicker to utilize arithmetic sequence formulas. Rather than creating your own function rule like y equals mx plus b or your quadratic equation, it's actually a lot easier to use these formulas. You take different parts of the sequence that actually make the sequence unique, and then you can just plug in these numbers into the sequence rather than having to solve for both x and y in these equations. It's a lot more efficient, especially when you have larger differences, like in the thousands. If you have a common difference of like 1,000 between numbers, like 1,000, 2,000, it gets a lot more confusing. And when you have odd numbers, really uncomfortable numbers, it's actually easier to utilize both of these formulas in their specific scenarios. So these are the major formulas, as I said, your explicit and your recursive formulas. We're going to go over the recursive formula first, and then of course we'll move on to the explicit formula. The recursive formula is something a lot easier to learn, and it's actually something you're already familiar with. It's just categorized and identified by different symbols in relation to the arithmetic sequence. And then of course explicit formula, that's a little bit more difficult, but it's a lot more useful when it comes to your more difficult problems and your more difficult sequences. So without further ado, let's move on to our recursive formula. So what exactly is the recursive formula? Well, I'll give you a simple definition to think about. Recursive. Recursive in mathematics means to continually repeat a process over and over again. Now, if you think about a sequence, the sequence never stops. It goes over and over again. So all we're doing is we're taking the properties of our arithmetic sequence, knowing that it's consistently going to be adding a single number to each digit to get to your next sequence number. We're going to utilize that process to discover what the nth term in a sequence is, a term that you might want to know. So the recursive formula, essentially what the recursive formula does is it relates each term of the sequence to its previous term. Now, if you think about it, you know that you're always adding, when you're given a single term in a sequence, you're going to add the common difference to that term to get to the next term. Now, in order to discover what that next term is, all you're going to do is you're going to take that previous term, and then add it by the common difference. That's all we're doing. We're making it in relation to the previous term of the sequence that's already given to us. And the equation includes an initial value and a rule that defines the sequence. So, of course, you can involve your initial value and a rule that will define the entirety of the sequence when it comes to your overall arithmetic sequence formulas. But for this specific formula, we're only going to be focusing on the previous term and the common difference. So this formula will allow you to find the next value in a sequence in relation to the previous term that you're already given. And the equation looks like this. It looks like a of n equals a of n minus 1 plus d. That's the whole equation in subscript form. And I'll explain what each and every single one of those counterparts actually mean. So a of n is essentially what you're looking for. A of n minus 1 is supposed to be your previous term, and then d is supposed to be your common difference. So that's supposed to say common difference. I apologize. Common difference. So d is your common difference in this case. And then, of course, like I said, a of n is your nth term, and a of n minus 1 is your previous term. So your d being your common difference, remember, your common difference is essentially the difference between the sequence numbers. That's going to stay the same for the entirety of the sequence if it's a linear sequence, which is what we're going to be looking at. So that common difference between each and every single consecutive term in the sequence is what we're going to be assigning as d. A of n being your nth term is what we're actually calculating for. It's the term number. It's the actual sequence number that you're looking for. So if you're looking for the 10th term, you would essentially be plugging in, a of n in place of your n would be 10 in this case. So you'd say a of 10 if you're looking for the 10th term. And then, of course, you'd calculate that on the right-hand side. And then, of course, a of n minus 1. That's basically your 9th term if we're putting it in terms of a of 10. That's your previous term, one term before that. You're going to put the actual number, the value of the sequence number, you're going to plug that in, you're going to add it to your common difference, and then you're going to get your next term. That's all you're doing here. You're taking the previous term, adding it with the common difference, and then you'll get the next term. Just common logic. All right, now let's do some practice with the recursive formula, actually putting it into action. So let's use the recursive formula to find the next term in the sequence below. We're given this sequence. As you can see, this is how I like to organize it, and this is how most courses like to organize it. You'd put on top your term number, being your domain, your x values, if you're going to think of this as a graph, and then on the bottom part, you're going to put your sequence. It's like your range, your y values. It's your actual sequence numbers. So for our sequence, we have our first term is 3, our second term is 253, our third term is 503, and our fourth term is what we're looking for, x. So as you can see here, compared to our previous video, these are actually much larger differences, and that's where these formulas really come into play. So let's take a look at our equation. A of n equals a of n minus 1 plus d. We're solving for x. Now we know that the recursive formula, we're going to be utilizing the previous term and then adding it to our common difference to get our the term that we're looking for. So let's identify first what the common difference is. So we know that the difference between 3 and 253, the first and second term, is 250. Then the difference between the second and third term is also 250. So we know that our common difference is going to be 250d. And of course, since a of n is our fourth term, so it's going to be a of 4. Since it's our fourth term, n is substituting for that term number. We're just going to subtract 4 minus 1 as a of n minus 1. So 4 minus 1 would be 3. So now we're looking for a of 3, our third term. And we know that our a of n minus 1, or our a of 3, our third term, is going to be 503. So that's the previous term to what we're looking for. And now all we're going to do is we're going to substitute a of n minus 1 for 503. We're going to substitute, a of n minus 1 we're going to substitute for 503. We're going to substitute d for 250. We're going to put 250 in as our common difference. And then, of course, we're going to put x in place of a of n, the term that we're actually looking for, the fourth term. So now all we need to do is we're going to add our previous term with our common difference, 503 as our previous term, plus common difference 250. And we get our answer as 753. So that means the fourth term in this sequence is going to be 753, what we're looking for, a of n. As simple as that. The recursive formula is rather simple. It's a lot of logic in place, but of course we can always put this in a formula format just so that you get to understand this process and understand arithmetic sequences forward. But in reality, once you get comfortable with this, you won't need to write it down as we get into more complex sequences. All right, now let's move on to our second formula and our last formula, our explicit formula. So what exactly is the explicit formula? The explicit formula is used in used for any single arithmetic sequence that you're given a linear arithmetic sequence, and it's used to find any specific term within a sequence. So this doesn't just limit you to the previous term. So you don't have to necessarily, like the recursive formula, you can only find the next term in the sequence. However, with this explicit formula, you need more information, you need more variables, and you need more variables in the equation, and you need more information about the arithmetic sequence. And once you get more information about the sequence, then of course you can calculate for any specific term. For the recursive formula, you need less information. That's why there's the difference between the explicit and recursive. But you can find any term with this equation, with this formula. So you can create the formula using the unique components of the sequence just as you would a function rule. So you'd start off looking for values that would include the initial value of the sequence, the previous term, and the common difference. These are some of the three variables that you'd be looking for and you'd be calculating for. And then of course you'd combine them in a specific manner to actually calculate for any term that you want, your nth term, any term in the sequence. So here's the equation. A of n equals a of 1 plus n minus 1 times d. A of n is going to be, similar to what we saw before in our previous equation, just like your d value, but there's some different twists to this equation, like your a of 1 and your n minus 1 not being a subscript value. So let me go over these variables. So d is actually going to be your common difference, like we always show, like I've shown you as always. D is just going to be that common difference between every single consecutive sequence term in the sequence. And then a of n is going to be your nth term, the term that you're actually looking for. We can substitute that for any variable like x. And then of course a of 1 is going to be the initial value or the very first value of the sequence. And then of course, just as a side note, n minus 1 is just going to be your previous value. It's going to be a previous value, and it's not going to be in subscript form, essentially. It doesn't matter. It can be a of n minus 1, but it's just going to be the previous value of the term that you're looking for. So you do need the previous value as well. So let's practice this explicit formula. So let's use the explicit formula to solve the problem below about a rental home. So we have this rental home here, and this rental home, every month that you rent out this home, it's actually going to increase in price at a consistent amount after a certain amount of months. After 4 months, it's going to increase consistently for those 4 months, and then afterward, it's going to start to plateau at that same price. So as you can see here, for the first month we have $1,500. The second month we have $1,830, and then the third month we have $2,160. So now we're calculating for what the fourth month will be, the next month, as x. So let's take our equation. A of n equals a of 1 plus n minus 1, and of course that's multiplied by d. That got cut off a little bit. I apologize. Let's just write that here. Times d. So it's going to be multiplied by your common difference. So let's calculate what the common difference is first. So we see that $1,500 and $1,830, the difference between them is $330. And then the difference between $1,830 and $2,160 is also $330. So that's going to be our common difference here. So D equals $330. Then, of course, we're going to substitute x for our a of n. A of n is going to be our fourth term, so we're calculating for the fourth term as x. And then finally, a of 1, the very first value, the initial value of the sequence is going to be $1,500, and it's, of course, our first term, as shown in a of 1 as a subscript. So now let's start to plug in those values. We plug in x for a of n, we plug in 1,500 for a of 1, then we're going to take that term number of x that we're looking for, so we know that n is equal to 4, a of n, we're looking for the fourth term, so we're going to subtract 1 from 4, then we get 3, and then of course we're going to multiply that by 330, our common difference. Then of course we're going to finish it off by multiplying 3 and 330, that's 990, we're going to add that to 1,500, and you're going to get 2,490. So that's your final answer there. And that was done entirely by using this simple formula. It's a lot easier to use, and as you can see here, with appreciating and depreciating values of larger sums of money, you have uncomfortable numbers like 330. It's an odd number. Sometimes you even go into the decimals, so it's easier to use the explicit formula rather than taking the hassle and possibly making a computational error because you're not seeing everything in full with a function rule. So I do recommend using these formulas when it's best suited for you. Otherwise, you can use mental math and basic logic. Alright everyone, so that'll be it for today's video. I hope you guys enjoyed. This has been the eCoreAcademy e-learning platform. Please make sure to like and subscribe down below. Also feel free to leave a comment and share this video through YouTube. Check out our website at www.ecoreacademy.org. Check out what kind of interesting content we have there. We have full note sheets, quizzes, and worksheets that go along with each and every single one of our videos, so check that out. We also have our email, eCoreAcademy@gmail.com, up on the screen, so feel free to utilize that email. Ask us any questions, or just reach out to us if you'd like. And finally, visit all of our socials in the description down below: Pinterest, Facebook, Twitter, Instagram, TikTok. See what kind of interesting content we have there. Alright everyone, so that'll be it for today's video. I hope you guys enjoyed. This has been AJ, and I'll see you guys in the next one. Peace!